Hey guys, welcome to our new video. Today we are going to discuss about how to post convert the files which you are getting after running the simulations using Sigin and also using Converge. So there are basically two ways to post convert your files. Okay, the files which you get after running the simulation, that post.out files, right, that you need to convert into the form which ParaView can understand, right? Then only you will be able to post process the results. So basically there are two methods. One is you can do that in Converge, and second is by using the commands in Sigin. So both the methods are easy. So I will first go with the Converge Studio. So let me launch Converge Studio, and here is the 3D post processing tool, right? So you have to click here, it will take you here, and you have to give the case name as test or anything which you feel like, and you can select ParaView VTK inline binary format. Okay, and you can go to the directory in which your post.out files are already dumped while running the simulations, correct? So I'll go to that directory. Let's say this is the directory, select. So presently I don't have any post.out files, okay, but if you go to the correct directory, here there will be the list of post.out files. Okay, then you have to click on all, and here also all, and if there are some parcel variables present, you have to click all, and then this convert option will be unfreezed and you have to click on convert. So here it will take some time, and your all the files will get post converted. Okay, now the thing is, suppose you have a lot of post.out files, like 500 or 600 post.out files. So if you are running a very difficult case or very complicated case in which flow is very complex, so to capture the physics properly you might need a lot of post.out files. Okay, so suppose if you have for 500 600 post.out files, and if you are using Converge Studio to post convert it, it will definitely post convert all your files, but it will take a lot of time, right? Now suppose if you have 4 cores or 6 cores or 16 cores, right? Most of you will be having 4 cores or 2 cores. Okay, so instead of post converting in serial, we can do post convert parallel also. The way we run our simulations in parallel, we can also post convert the files in parallel. So to post convert your files in parallel, we need to make use of Sigin. Okay, so how to do that? So what we'll do is I will launch Sigin first. Okay, so let me go here, Sigin. Okay, now I will go to the directory. Suppose change directory D Converge runs Ahmed body list. So here, so assume that I have the post.out files. Now how to run the command, right, to post convert it in parallel. So now the command goes like this: mpi exec.exe hyphen n. Suppose you want to use 2 cores, to 2 post underscore convert underscore msmpi underscore 64.exe. Now if you hit enter, your Windows will ask you to give it the access. So you'll click on allow access. Now you will give the case name like test, right? Enter. Now the way you gave here the name of the case, right, test, here also similarly you have to give the name as test or any name. Now here you used to use VTK inline binary, right, file type. So here also you'll use the same. So here the VTK inline binary is 10 number, right? If you can see here, it's a 10th number, right? So what you can do is you can just type 10 and hit enter. Okay, now it is saying that ended prematurely, right? So because the file didn't found, because the thing is you should have files, right, to post convert. Here I don't have any files to post convert, that's why it is showing this error. Okay, so now some people or many of you will try this directly, so you don't have to do this directly. So if you go to your Google Drive where all the softwares we have provided, so here you can see these 2 softwares as well, these 2 files. Okay, basically, so where is Converge softwares? Yeah, so if you want to post convert your files in parallel, you have to have post underscore convert underscore msmpi.64. okay, so if you have to download this, then you have to run it. Okay, so run as administrator and follow the procedure. Okay, same goes for this also. Now the thing is, it is always a good idea to to create an environmental variable for these files. So what I did is I just copy pasted these two files in C drive. Okay, you can paste it anywhere. I preferred C drive. I pasted those two files in the C drive under program files, and I created a folder called post_convert. Yeah, post_convert, and here is the file post_convert_msmpi. So you have to also copy that file. Okay, serial. Okay, and then what you have to do is you have to just go on properties, go to advanced system settings, go to environmental variables, and in the path double click, and here you have to copy paste the address. Okay, copy paste the path basically. So which path you will copy paste? This path you will copy and you will paste it here basically, right? So I have already done that. I'll not do it again. So you have to do like this. Or another idea is, so suppose this is the thing, Control C. If you don't want to create a environmental variables, so wherever you have the you have the post.out files in that folder, what you'll do is, one sec. Okay. Oh, nice. So see here I have okay, no issues. Okay, I have the post.out file, one post.out file, right? So what I'll do is I'll show you the demo. Okay, so I have created the environmental variable, or else what you can do is you can just paste that file, okay, wherever you have the post.out file. Like this is my post.out file. I have one here only, right? So I will paste that post_convert msmpi64 here, and what I'll do is I'll basically go to Sigin. Okay, and I'll go to let me go back, directory list and change directory. Okay, so it's Mehul Ahmed list. Okay, change directory test503 ls. Now what I'll do is, see here I have post.out files also, and also post-convert msmpi, right? So what I'll do is I want to post-convert, right? So I'll do this msmpi So here I have, okay, so mpi exec.exe minus n2, suppose I have two cores, right? Post underscore convert underscore msmpi underscore 64.exe, enter. Okay, now I'll give the name as Mehul, let's say, enter. I'll use VTK inline binary format, enter. See, yeah, basically I think you have to always copy paste that post_convert msmpi64.exe in the folder in which all your post.out files are present. Okay, so here it is asking whether you want the boundary surface output. Yes, so it is asking yes for 1 and no for 0, right? So you can type 1 because you want, right? So 1, enter. Now it is asking please indicate the files you would like to include. So here is one file only, but if there are multiple, like 100 files, so what you will do is you will type all. You want to convert all the files, right? So all, enter. Now it is asking please indicate which variables you would like to include. Obviously we want all the variables to be post converted, right? You want to see density, pressure, temperature, velocity, correct? So all, enter. It has started doing post convert. Okay, so here it is, since it is one file, it will not make much difference whether you do it in Converge Studio or in Sigin. But if there are 100 files, right, and 200 files like this, so this way is better. It will post convert in a faster rate. Okay, now another thing is, since I talked about post convert and you should have this much 100 files, right? So I have noticed one thing, that people are not focusing on the numbers, right? Which numbers I am talking about is, if I go to Converge Studio in the case setup, so you can see here is the output files, right? No one is giving or observing the numbers in this file. Okay, if you go to output files, okay, okay, wait, yeah. So what I'll do is I'll just abort it. Okay, I just want to show you this thing. So this is how you will be doing. All right, so make sure that post_convert_msmpi, which is this file, right? You just run it, okay, after downloading it, and you copy paste that file or this executable in the folder in which your post.out files are already present, okay, already dumped. So you have to copy paste this, and then you can post convert it in parallel. So make sure you download this file and make sure you copy paste this file in the folder, and then only you will be able to post convert it in the Sigin. Okay, hope it is clear now. And yeah, so I was discussing about these numbers. So people don't care about these numbers, and these numbers are very important. Okay, so what I will suggest you is, so see, you should read this 4-5 statements. So time interval for writing 3D output data files. So what does this mean? This means ki in what interval your each post.out file should get dumped. Okay, so post.out files are nothing but the 3D output files, right, which you want because you need to post process the results, right? Then only you will be able to see all the contours of pressure, velocity, temperature, correct? So this is the reason why you have to look at this number. So suppose it is always a good idea, and you should be using this as a thumb rule, that in any simulation you are running, you should have 100 post.out files. So how you will decide? So this is the time interval of writing 3D output data files. So what does this mean? So it means in how many seconds you want your first post.out file should get dumped, or in other words, or in how much time interval you want your post.out files to keep on dumping. Okay, so, and I'm saying at the end of the simulation I want 100 post.out files, right? So what you'll do, it's a simple math, right? So you'll go to simulation time parameters, you'll see, okay, my end time is 0.75 seconds, right? I'm saying at the end of the simulation, when the simulation is finished, when you go to the output folder, you should be seeing 100 post.out files. So in short, I'm telling you, in 0.75 seconds I want 100 files. So can you calculate one file will be dumped in how many seconds? It's like simple math, right? So what I'll do is I'll just let me open Paint for you. Okay, so what I'm basically trying to tell you is, okay, let me use brush, black is fine. So what I'm saying, in 0.75 seconds, okay, I want 100 files. You will check your end time, okay, always. I want 100 files, 100 post.out files. So I'm saying one file will be dumped in how many seconds, right? This we have done in our lower classes, right? So what we'll do, you have to find the value of x. So what will be x? X is nothing but 0.75 divided by 100, correct, which will give you 0.0075, correct? So if you see here output files, it is 0.0075, correct? Now time interval for writing text output. See, text output is very in KBs, okay, very small files. So I want, or it is a good idea to dump text output data in each and every time step, okay? So it should be 1 e power minus 9 always. This you have to keep it constant, 1 e power minus 9, so that suppose let's say your end time is 0.75, right? So if you keep this as 0.25, right? Suppose you are keeping time interval for writing the text output is 0.25, right? So at how many discrete points you will get the data? So when you look at your line plots here, right? When you go here, when you try to look at the graphs, so the graph which you get at the end of the simulation, very smooth curve, right? So that is because you keep the time interval for text output data is 1 e power minus 9, very small number, that at each and every time step text output data should get dumped. That's the reason you are getting very smooth curve. Suppose if here in your case setup, right, end time is 0.75 seconds, right? If you see, so suppose I keep 0.25 as this time interval for writing text output. If I keep it this as 0.25, right, now you are running the simulation. So what will happen is, at the end of the simulation, when you see the graph, okay, how it will be looking is, let me show you example. So suppose you in the line plots you are seeing the pressure curve, okay, pressure curve against the time. So you are running the transients, it will be in seconds, correct time. So if you are keeping that 0.25, so what will happen, this is 0. After 0.25 it will show one data point, okay, 0.25, this is 0.25, okay, and now suppose it has dropped, so this is 0.25. After every 0.25 this data will be dumped, okay. So after 0.25 it will get dumped at 0.5, let's say. So another point, suppose there is some simulation in which pressure is increasing, decreasing, right, so it has decreased, so at 0.5, and after that 0.75, let's say it has again increased, so this is 0.75. So at 1, 2 and 3, only at 3 points you are getting the text output data, and with 3 points, so here to here it will straight line, so it will not give you the proper curve, right? In order to get the proper, suppose the actual graph should be like this. Suppose the actual curve is like this, but because you have 0.25 second as the time interval for dumping text output file, it is giving you only 1, 2, 3 dots, discrete points at which the data is there. So it will just connect the 2 dots via straight lines, right? So this will not give you the proper curvature or the proper variation of how pressure or temperature is varying with respect to time, okay. So it is always a good idea to have this number as low as possible, and it is 1 e power minus 9. Why 1 e power minus 9? I am telling you because in the, if you see the simulation time parameters, initial time step is 1 e power minus 9 and the minimum time step is 1 e power minus 9, right? So below this there is no low number, so minimum, so 1 e power minus 9, okay. Another thing, time interval for writing this restart output. Now this is very important. See, suppose you are running any simulation, okay, it's a very heavy simulation, you are running like IC engines or diesel engine or Ahmed body, okay, which will, in 16 core machine it is taking a week, okay, to complete the simulation. Now suppose you are running the no hydro case in your computer, which we asked you guys to do. It will take around 3 days, 3 to 4 days, okay, to run that simulation in your PC. So now let's say your simulation was about to finish and there is a power cut. Now if the power cut is there, your simulation will stop, okay. Now when you'll again switch on the laptop, and if you don't have any restart output files, you have to run it again, right? So it's a waste, right? Whatever you did for last 3 days, everything is a waste. So in order to get rid of all those things, okay, the simulation may crash because of multiple reasons, power cut, memory issue, anything. So to get rid of such issues, Converge provides you a good feature of restarting the simulation. So for restarting the simulation, you should have restart files, right? If you don't have restart files, how you can restart your simulation? So what we suggest is you should have 100, I mean the number, so 0.0075 is the number I am giving here. It means it will generate 100 restart output files, right? So in 0.0075, one restart output file will be dumped. So Converge gives one more feature as maximum number of restart files saved. So suppose it is a good idea to save 3 files. So suppose at 0.0075 one restart file is dumped, it will be there. Now after another 0.0075 interval, second restart file will be dumped, and so on. So once the 3 restart output files is there, it will be saved. Now after third out restart file. After that, after 0.0075 seconds, fourth restart output files will be dumped, and simultaneously the first restart file will be deleted automatically. Okay, so it will be saving only the last 3 restart output files, not all the 100 files. So what is the benefit of this? It is you are saving the memory, right? So there is no reason to keep all the restart output files, right? Why we are saying last 3 files? Because if suppose you are keeping one, okay, you have so suppose you are generating second file is getting dumped, the first file will be vanished. So in that case, the drawback is, suppose you're running the simulation, so first file is dumped, second file is dumped, and when third file was about to dump, okay, there is a power cut. Now it will dump the third file, but there are higher chances that the third restart file might get corrupted. Okay, so if the third output file or the restart output file is getting corrupted and you try to restart your simulation, it will not get restart because it got corrupted. So in that case, what we'll do is we will manually delete that restart output file, third restart output file, and since second is there, second restart output file, so it will start from the second restart file. So whenever the second restart file was dumped, from that particular time your simulation will start. It's like a you can say factor of safety. So that's why we are keeping 3 restart output files to be saved, okay, to be on the safer side. So I experienced a lot of students are not focusing on this number and they're facing a lot of issues. So that's why I thought of including this part, and it will be easy for you guys to understand the things. So, and another thing is, so in IC engine course, we don't have to worry about this generate wall boundary averaged output. Okay, there is only generate mixing related output we used to do, because in IC engines we have the chemistry going on in the air and fuel is getting mixed and exhaust gases are forming. There is a lot of chemical reactions happening in the combustion chamber, so we want generate mixing related output, right? But we are not interested in the wall boundary average output. So where it is used, right? So it is used in the aerodynamics course, external flow simulations, right? Like a flow over an airfoil, flow over an Ahmed body. So there we are interested in knowing what is y plus, right, near the wall, what is shear stress, what is the velocity profile getting generated, okay, what is the lift force and the drag force experienced by the body. So in that case we need a wall boundary average output. Okay, so in aerodynamics, in turbomachinery, we need our wall boundary average, because in turbomachinery, right, impeller is moving, right? So how much torque is getting generated on the blades of the impeller, right? And all these things, so we need that. So yeah, so these all things are must, and people don't focus on this part. So we thought of generating a video or creating one video on this, and yeah, so this is what I want to explain you. So now onwards, I believe that you guys will take care of these numbers. Make sure there are 100 Post.out files. Check your end time and make the calculations as I showed you, right? And you should have 100 Post.out files and make the calculation such that restart files are also 100, but it will save only 3 files. At the end you will get only the 3 files getting saved. But yeah, it is always a good idea to have calculation based on 100 restart output files. Okay, so with that, I would like to conclude this video, and if you are having any issues, just you can ask in support sessions. And so thank you guys, see you.